Alright, right now we on the core. The core how to solve quadratic equations. So basically we need to use the null factor theorem, and this is the core idea. So who didn't watch the previous video about the null factor law, it's very necessary to do that right now, but briefly I just try to tell you the core of the null factor theorem. So null factor theorem tells you that you have two factors, a times b equals 0, and just simply what you're gonna do, you just need to state that if the result is 0, you have a equals 0 and b equals 0. Instead of a and b, there might be the whole expressions, like the following: 3x plus 1 times, let's say, x minus 1. That's two factors. However, the null factor theorem applicable to two more factors. It might be like another factor, x plus 1. However, for quadratic equation, less likely you'll have three factors in a row. Just maximum two factors containing x. So the other, like third factor, might be a number. Okay, number never be 0 because the number obviously either positive or negative. In this case, we just need to equate all factors to 0 because they have a chance to be 0, because the result on the right side is also 0. And from where you can easily solve each small equation and find solution. Okay, that's in brief. All right, now how to use the null factor theorem or null factor law when solving quadratic equations. So that's the core, how to solve quadratic equations one more time. So we have to get the 0 on one side of the equation using the following steps. So first we need to rearrange equation. So on one side we have 0. For example, let's consider that one, x squared equals 4x. So we have both variables or both unknowns on two sides. So that's why we need to rearrange equation so one side is 0. So the best way is to transfer all terms in one side and collect them out. So x squared minus 4x equals 0. So we've done the first step. So the next step, fully factorize the other side. So usually left-hand side. And indeed, we have that on the left-hand side because right-hand side of the equation is 0. So we accomplished step 1. Okay, so let's do it. How to factorize? Try to find common factors. Common factor is only x, and we have x minus 4 as the other factor. Okay, we have two factors, and then we can apply step 3. Step 3 is about null factor law. So remember, a times b equals 0. In our case, we have x times x minus 4 equals 0. So how to apply? We just need to say that each factor, a and b, might be 0. So we do the same here. X as one factor is 0, and x minus 4 is the other factor that might be 0. Step number 4, just solve that. It's already a solution, and the second solution is x equals 4. Check at least one of your solutions. So actually, guys, I recommend to check both, and you know how to do that. You need to put those solutions into the original. So one more time, into the original equations. You need to check always original one, because if you like plug it here somewhere, before you already might have any mistake or errors. So that's why, to escape that illegal way of checking, so just always put your solutions into the original equations. So how to check it? Just put, whenever x stays, your solution. We first start putting 0 in both parts, because in both parts we'll get x. So 0 equals 4 times 0, so finally we've got correct equality. Okay, let's put x equals 4 in both parts, so we'll get 4 squared. Let's say it's 4 times 4. It's 4 times 4. In this case, we'll get 4 squared equals 4 squared, so also correct. So both equations correct. And both, solutions also correct. So you found that. All right, so let's try to practice through little problems here. So we have several of them. Pause the video, try to do by run, and then check with mine. Okay, so let's do step by step. First, we rearrange. We're taking the first one, x squared equals 4x. So for step number 1, just rearrange, and this is necessary here. X squared minus 4x equals 0, so that we reach 0 on the right side. Then factorize. X minus 4 equals 0. Then apply null factor theorem and complete 2 equations. I already solved the second one. Okay, maybe it's too early. I won't time write that. And finally, we have solutions x1 equals 0, x2 equals 4. And just check, so put that back. Okay, we've done that. Let's try to do another one. Oh, actually, I explained the first one the same. All right. Yeah, that's less like that was very low probability of getting or pick up the same number, but actually I explained it before. All right, let's practice with that one. So we have 4x squared minus 3x. It's already rearranged so that 0 is on the right side. So we just simply factorize and we'll get x is the common. So 4x minus 3, result is 0. How to solve that? Simply say x1 is 0, one factor is 0. We apply the null factor law. And 4x minus 3 is also 0. So we'll get the following: x2 equals 3 over 4. All right, I'm not going to check because I'm pretty sure I'm correct. So the second one, oh, we've got a bit more complicated stuff. X squared plus 11x, and we rearrange so that we'll get 30 here. Okay, so we've got x squared plus 11x and plus 30 equals 0. Now, what do you need to do? So actually, it's all about factorizing, and this is the right time to check your ability to factorize. Okay, we have to know several ways. In this case, I'll show you like 2 ways how to do that through the quadratic formula, which we'll be talking a bit later, or through just simple factorizing, just trying to, pick up the right form, like x plus a and times x plus b, and from here figure out what a and b might be. Okay, so right now I'll try to use that way. Okay, so let's try to do using that way. We've got 11x and 30. So if we start expanding the brackets, I'll show you why is it so. X squared plus ax plus bx and plus ab. That's what we have when we expand it. This is sort of like general factorized form, right? Factorized form. So we have this as expanded form. We expand it. And then it's right time to do the following. So we just take in ax plus bx and factorize x within that in order to have the same structure as you had here. So now let's compare x squared plus x times 11, or 11x, okay, I'll write the same way, 11x, and then plus 30. Okay, what we know by comparison? We know obviously that the product should give us 30. So AB must be definitely 30. And coefficient before x, which is a plus b, should be equal to 11. Because we are going to have this form equivalent to factorized form. That's why we can do comparison, or make comparison and compare all terms each term by each term. So for example, x squared we don't compare because they're simply the same. So we don't need to do that. Okay, So we have the product AB to be 30 and A plus B to be 11. So, okay, now a lucky guess. You missed, but here is also a way to practice your guessing techniques and strategy. It's not only about SAT. Here is also you can do. All right, so A times B is 30 and A plus B is 11. I'm guessing that A is going to be 5 and B is going to be 6, because 5 times 6 and you'll get 30. They might be like swapped, and A might be 6, B equals 5, but we don't care because they like symmetrical, they are identical, and you don't care what stays for instead of A and B, except for like both the product and addition should be the same, should be correct. Okay, in this case, I guess that A is 5 and B is 4. So I bet that they are a solution, because if we add them up, 5 and 6, just check, we'll get 11. So they are both correct, and that's why factorized form that we have here is the following. Instead of A, we put 5, and instead of B, we put 6. This is factorized form. So don't worry if you don't get how it works. So maybe just try to pause the video, try to analyze what I've done here. I've just applied general factorized form and just make a comparison. I didn't use quadratic formula. But in the second one, I'll show you how to use quadratic formula. Okay, so how to get solution? We equate by null factor theorem each factor to 0, and we'll get it from the first solution is -5, and the second solution is -6. Okay, so let's try to practice with that one. This is on a range, so we need to arrange that first. We transfer all items, all terms on one side. So we get that one, right? Just compare. Just compare with the previous one. X squared equals 11x minus 24. So we transfer all terms to the left side. Okay, here I'll show you how to use quadratic formula. So basically, it's ready to use to determine solutions. It's already about not how to factorize, but already how to solve that. So you'll use the formula -b plus minus square root of discriminant over 2a, where you have the form x squared plus bx plus c equals 0. In our case, a is 1, so imaginary 1 stays here, b is -11, and c is 24. So discriminant is specific like combinational expressions, which is equivalent to b squared minus 4ac. Okay, just simply use that quadratic formula and try to solve that. So we'll get minus b, which is minus 11, so it's positive 11 square root of b squared minus 4ac, so b squared is 121, it's square number, and minus 4 times 24, so we'll get 96 over here and over 2. So let's see, if we simplify that, we'll get 121 minus 96. I guess we'll have, yeah, looks like 25 here. Let's check. 96 plus 20, right, and plus 5, so we'll get 116, yeah, and plus 5 is 121. So we'll get 25, and square root of 25 is simply 5 over 2a. Okay, over 2. 11 plus minus 5 over 2, and we immediately get a solution. 11 plus 5 over 2 is 16 over 2 is 8, and x2 equals 11 minus 5, which is 6 over 2 is 3. Okay, we've got solutions very fast, but we didn't use the method that discussed previously. I intentionally give you here for comparison. This is what is called quadratic formula. But if you're told using factorizing, hence solve, so don't use quadratic formula. Just try to use the first way through general factorized form, for example. You might use also alternative way, and I'll show you for number 3. So actually this is like a distinct topic that is called factorizing, but I'll try to show you here because right now I don't have this video, so it's going to be soon, don't worry. And that's why I just comprise several topics in one. Okay, so let's do that one. X squared, 3x, and 70. What I'm going to do, I'm just first trying to rearrange x squared minus 3x and minus 70 equals 0. And now I'm thinking about how to factorize, how to make from, let's say, this expression something similar to what we've got here. Okay, so what can we do here? Let's try to analyze. So normally, if we use the previous method, we need to get x plus a, x plus b equals 0, and the product should be 70, so ab should give you 70, while, negative 70, and the sum of coefficients should give you negative 3. So it looks like it's sort of like big numbers, but right now what I'm gonna do, I'm trying to evaluate what actually I might have here. So let me see. We've got the following: 70 as the product, right? Okay, and take that. So actually I use quadratic formula because in this case it's quite tricky to factorize like from scratch. So I got this, and from where I can have 3 plus 70, 20 is 10, and x to 3 minus 70 is minus 14 minus 7. So it looks like we have the following: x minus 10 and x plus 7. And indeed, if we factorize, we'll get the right answer. Okay, so now let's try to do it by just, by trying to use the previous method, because of the methods is hard to apply here. So what we need to do, the product is negative 70 and the sum is negative 3. So I actually use quadratic formula, and I already got solutions. However, I just checked that by using my method about the product and the sum. So what we can do, a times b, the result should be negative 70. Okay, we still have like unknowns, and let's try to compare. So we've got the product is negative 70, so good numbers might be negative 10 and b, let's say, is 7, or we might have a equals 10 and b equals negative 7. All right, so which values to pick up? So we know that the sum should be negative 3. All right, looks like this fits better. So we erase that because 10 minus 7 will get 3, but we need to have negative 3. In this case, that's solution, and hence we'll get x minus 10 times x plus 7, from where, equating each bracket to 0, we'll get x1 equals 10 and x2 equals negative 7. In this case, that's okay. Okay, and the last one, oh, we have several ones. Yeah, what we're gonna do, I think that numbers will keep up to revision because it's pretty enough, and information, you not be overloaded with information. So let's stop here and just continue in the next video to consider what if you have like sort of quadratic expressions and equations that contains leading term with non-1 coefficients. So in other words, right now you have the chance to know how to solve general equations in this way. Okay, But keep in mind that in this topic, you need to feel very confident in yourself in factorizing. So factorizing is the core idea. If you have unfactorized expressions like we do have here, or equations. Okay, so just I hope you enjoyed that. However, like the factorization methods, I decided to combine here and just embed it. Maybe it's not like right, and for that, for sure you need to have separate video to watch. So I encourage you to watch factorized form, how to do that, how to use like several approaches through quadratic formula and actually through general factorized form, or somehow through splitting the middle term. I guess that is going to be a separate list of videos on my channel. So guys, keep practicing, try to do factorizing as the primary methods here, and then just follow the steps that we've done here, how to solve quadratic equations. Okay, hope you enjoy one more time. Don't forget to subscribe. For subscribers, I get the chance to give some comments what specific videos they require. So don't hesitate, just write the comments what exactly you need to refresh before passing GCSE exam, before passing mocks, or just, succeeding your current topics. Subscribe, share your ideas, and you'll get the feedback, guys. So with me, you'll definitely succeed. Hope you enjoy, and see you.